Hello and welcome to today's lesson. We're going to be talking about how to display and compare data sets. So that means you're going to need to know how to compare and contrast the mean, median, mode, and range of different groups of numbers, and that you're also going to be able to have to know how to be able to draw and evaluate different types of graphs such as box plots, scatter plots, histograms, and also know the difference between continuous and discrete data. So we're going to be going over all the definitions of those and examples, so you want to make sure that you're taking good notes so that you have all of that information written down in a place that you can reference when you're trying these problems on your own and studying. If I ever go too fast, just pause the video and rewind so you can get caught back up. I'm so glad that you are joining us today, and let's go ahead and take some notes.
To do this lesson successfully, we need to remember what mean, median, mode, and range are and how to calculate them. So anytime you're calculating these, especially for the median, mode, and range, it's helpful to have the numbers in order by size, from smallest to biggest. The mean is the average of numbers. You calculate that by adding all the numbers together and dividing by how many numbers were added. The median is the middle of the number sequence. So just like the median of the road, that's the middle of the road, that's the middle of the numbers. So the median is the middle number when the numbers are arranged in order by size. And if you have an even number of numbers, then you take the average of the two middle numbers. Mode is the number that occurs most often, so MO. And to do that, you find the numbers that occur the most often in this sequence. There may be more than one. So you could have two numbers that occur 3 times, and those would both be the mode. Then the range is the difference between the lowest and highest values. So you're just subtracting the smallest and largest number to find the range. So go ahead and make sure you have this in your notes. If I went too fast, just pause and you can get caught back up. Here's a little rhyme just to help you remember all the meanings. Hey diddle diddle, the median is in the middle. You add then divide for the mean. It's the average. The mode is the one that appears there most, and the range is the difference between. So for this first example, it says, in Mrs. Johnson's 8th grade homeroom, the students are measuring and recording how far their locker is from the classroom. The distances the 5 girls' lockers and 5 boys' lockers in the classroom are recorded in the table below. Which statement best describes the means of the two sets of data? So here, in order to compare and contrast the two means, we're going to need to find the means of the girls' locker and the mean of the boys' locker. So you find the mean by adding up the numbers and dividing by the number of numbers. So for the girls, I'm going to be adding up those 5 numbers. So that's going to be 10 plus 7 plus 11 plus 7 plus 10. And there's 1, 2, 3, 4, 5 numbers. So I'm going to be dividing that sum by 5. So 10 plus 7 plus 11 plus 7 plus 7 plus 10 is going to be 45. Divided by 5 is 9. So the mean of the girls is 9. And then I do the same thing with the boys. The boys, I'm going to be adding up these 5 numbers, which is 10 plus 7 plus 11 plus 7 plus 10. And there's 5 numbers there too, so I'm going to be dividing that by 5. And the sum of those 5 numbers is 55. 55 divided by 5 is 11, so the mean of the boys is 11. So the mean of the boys' distance to their lockers is larger than the girls' locker by 2 feet. So the one that says that is B. The mean of the distance of the girls' locker is 2 feet smaller, less than the mean of the distance to the boys' locker. So that means B is going to be my final answer. This problem says Christina and Victor like to play cards on Friday night. The scores of 5 hands have been recorded below. What statement best describes the median of the two sets of data? So in order to compare and contrast the two medians, you're going to have to find that median first. So to find the median, that's the middle number, we need to put these numbers in order. So I'm going to go ahead and put Christina's 5 numbers in order here. And when I do that, it looks like this. And I always like to double check that I have the same number of numbers that I started with and ended with. So here there's 5 numbers and I have 5 numbers. So I didn't miss any when I was putting them in order. And then I'm going to do the same thing for Victor. And when I do that, it looks like this. So now I just need to find the middle number of both of those. And so one way that you can do that is by just crossing off numbers from the beginning to the end. So like this. So 42, 45, one from the beginning, one from the end, and I can see 44 is that middle number. And I do the same for Victor. One from the beginning, one from the end, beginning, end, and I can see 37 is that middle number. So I look for an answer. And choice A here says that Christina's median score is 44, which it is. And Victor's median score is 37, which it is. So that means A is going to be my final answer. This problem says Mrs. Brighton and Mrs. Carson both teach 8th grade math. The mean scores for the 5 tests in each class have been recorded below. Which statement best describes the mode of the two sets of data? So mode is the number that occurs the most. So if I look at Mrs. Brightman's, 91 occurs once, 89 occurs once, 92 occurs twice, and 90 occurs once. So 92 occurs the most times. And I can look at Mrs. Corson, 84 occurs once, 87 once, 86 once, 81 once, and 83 once. So this one doesn't have a mode, because each number occurs only once. So which statement below describes the mode of both sets of data? A, they're both equal. That's not true. We have 92 and none. There's no modes for this data set. Well, there's no mode for the second one, but we have one for the first one, so it's not B. C says Mrs. Corson's class, the mode is 87. Well, Mrs. Corson's is none, so it can't be C. D says Mrs. Brighton's class, the mode is 92. That's correct. And there's no mode for Mrs. Corson's class. That is correct also. So that means my final answer is going to be D. This problem here says James and Elizabeth both like to run. Their times for running 2 miles are recorded in the chart below. Which statement best describes the ranges of the two sets of data? So we're going to need to find the range for James and for Elizabeth. The range is subtracting the largest value from the biggest value. So if I look at James, his smallest value is 14, and his largest value is 18. So for James, we're going to take 18 minus 14, which is 4. And if this was a big set of data, it would be advantageous to put those data points in order from smallest to biggest, so you'd make sure that you didn't miss one. Because if you miss the smallest one and pick another number, it's going to mess up your whole answer. So for Elizabeth, we're looking at hers, and her smallest value is 12, and her biggest value is 18. So you're going to take 18 minus 12, and her range is 6. So then we just go through, now that we know the ranges, we're just going to go through the answers and see which one matches up. A says there is no difference between their ranges. Well, one's 6, one's 4. There's a difference. So it's not going to be A. B says James has a larger range in his times than Elizabeth. So James is 4. That's not bigger than 6. It's smaller. So it can't be B. Their ranges cannot be determined from the data given. Well, we just determined them, so it's not going to be C. And D says Elizabeth has a larger range in her times than James. So 6 is larger than 4, so D is going to be your final answer. Next, we're going to be looking at box and whisker plots, and this is an example of the box and whisker plot. So we're going to need to know how to create a box and whisker plot and the parts of a box and whisker plot. So you can see that this is the box, and there's a line coming off of each side, and those are the whiskers. So the first whisker is going to start at what's called the lower extreme, and that's just the smallest number in your data set. And then it's going to be connected to the box, where the box starts out at the lower quartile. The lower quartile is the median of the lower half of the set of data. And then there's a line in the middle of the box where the median is, and the median is that middle number of all of your values. The box then goes and ends at the upper quartile, and the upper quartile is the median of the upper half of the set of data. And then you have another whisker that extends from there and ends at the upper extreme, and it is the largest number of a set of data. You can also have outliers. This example here doesn't have an outlier, but an outlier is shown by an asterisk on the graph. So if you had an asterisk down here, that would be your outlier. And then lastly, you can be asked to find the interquartile range, or IQR, and that's the difference between the first quartile and the third quartile. So that would be the difference between the lower quartile and the upper quartile, how big your box is. So here, that would be 85 minus 50. And just another thing to note is that each part here is 25% of your data. And that's a big characteristic of box and whisker plots. So once you get that all done in your notes, press pause, please, if you need to, and go ahead and continue. So I talked about how to create a box and whisker plot on the last slide, and here are all the steps written out for you also. So in case you couldn't get the steps all written as I was speaking, here they are written out for you also. So you can go ahead and write this down in your notes also. If you need to press pause so you can get it all before I move on, go ahead and do that, and then come back and join us. This next question says, Josh is a server at a restaurant. The data above displays the amount of gratuity or tip in dollars that he earned from each table that he served on a given night. Which of the following box plots represents the data set above? So we're going to have to go ahead and calculate the lower extreme, the lower quartile, the median, the upper quartile, and the upper extreme. So what we're going to do is we're going to put these numbers in order first. And when you do that, it's going to look like this. And so like I said, I always like to double check that I have the same number of numbers as I do in the problem as I do written out here to make sure I didn't miss anything. Especially if I can't cross them off because it's on a computer screen. But if you can cross them off, I highly recommend that you do that. So we're going to have to first find the median of these numbers. So, and you can just do that by starting at the beginning and the end and finding out which number is in the middle. And 15 is in the middle. There's 7 numbers below it and 7 numbers above it. And then we're going to need to find the median of the lower set of data. So that's going to be 5 through this 15. And so since there's 7 of them, that means I need a number that has 3 below it and 3 above it, and that's going to be 10. And I need to find the upper median, or upper quartile, which is going to be the median of 18 through 50. And that's going to be the 20. And so then I just need to find my lower extreme and my upper extreme, which is the lowest and biggest number. So here my lower number is 5, my lower extreme. And now 50, that's an obvious outlier. So while that is my biggest number, I'm not going to include that in my box plot because it's an outlier. I'm going to make 25 my upper extreme. So here, I'm looking for a whisker that starts at 5 and goes to the 10, and a box that goes from 10 to 20 with a line at 15, and then the upper whisker ends at 25 and then has an asterisk to show the outlier at 50. And so I'm looking for that above a number line that's correctly done. And so here I have 5 and the 10 and the 15 and the 20 and the 25. So this all lines up, and then an asterisk at 50. So W is going to be the choice that I want, which is a final answer of D. Here, number 7, the box plot below represents the number of absences per student over a semester by a group of seniors at Green Hill High School. Using the box plot above, which of the following are true regarding this data set? So the first one is saying the interquartile range is 10 days. To find the interquartile range, you subtract the end of the box from the beginning of the box. So it ends at 5 and begins at 1. So 5 minus 1 is 4, not 10, so it's not going to be choice 1. And it says the median is 2 days. Remember, the median is the number below the line in the box, which is 2 here. So choice 2 is a good one. And we have to check all of them because there's going to be 2 that work. Choice 3 says about 50% of seniors missed from 1 day to 5 days over the given semester. Remember, each piece here, the line, this part of the box, the beginning of the box, the line to the end of the box, and then also the last whisker are all 25%. So if you have 2 of those pieces from 1 to 5 days, that'll be 50%. So from 1 to 5, I do have 2 of those pieces, so that's 50%. So 3 works. And then 4, I'm going to see if it says about 50% of seniors missed from 5 days to 10 days. From 5 to 10, I just have the one whisker. It's just one piece. So it's only 25% of seniors. So it can't be 4. So the choice D here is the one that says 2 and 3 are true. So that's going to be my final answer. This problem here says in the Lake Woods area, there are 3 different neighborhoods: Water Spring, Westwoods, and Williams Creek. The number of houses on each street in each neighborhood is given in the table below. How does the upper quartile of West Spring compare with the upper quartile of Westwoods? So to find the upper quartile, I have to find the median of the top part of the data. And it's just asking about Water Spring and Westwoods, so I don't really need to do anything with William Creek for this problem. So to find the upper median, I need to put the data in order for West Spring and for Westwoods. Put those numbers in order, it's going to look like this. The first step in finding the upper quartile is to find the median. So the median of Water Spring is 11, and the median of Westwoods is 9. So then I need to find the median of my upper 2 numbers for both of these. The middle number between 12 and 12 is going to be 12. The middle number between 14 and 16, the middle number in between there is 15. And if you weren't sure of that, you could find the average of 14 and 16, add them up and divide by 2. So here, the upper quartile of Westwood is greater than the upper quartile of Water Spring. So we need to find the choice that says that. And the one that says that is D, where it talks about West Spring being smaller or less than Westwood. So that's going to be my final answer. The other type of graph that you could see in this section is a scatter plot. And just as a reminder, a scatter plot is a graph of plotted points that show the relationship between two sets of data. And here's examples of scatter plots. So in this problem, they give us this table that contains data on the relationship between the height and shoe size of several women. And they want to know which scatter plot shows the same data. So if you look, the height is the x-axis in all of the choices, and shoe size is the y-axis in all the choices. So you can't eliminate anything that way. So you're just going to have to look at this point. So this first column, 54, 5, is like your coordinate point. And you just need to see which one of those scatter plots have that coordinate. And it might be all of them, or we might be able to eliminate something. So if I go to 54 and up to 5, there's a point. 54, 5, point. 54, 5, there's a point. And 54, 5, there's a point. So they all have that point. So then I go to 57, 6. So 57, 6, there's a point. 57, 6, there's a point. 57, 6, there's a point. And 57, 6, there's a point. So then I try 60 and 5.5. So I go to 60 and 5.5, there's a point. 60, that one goes to 6.5, so I can now eliminate x because that point is incorrect. And then I'm going to go to 60, and this one also goes to 6.5, so I can eliminate y. And then z is 60 and 5.5. And so now I'm just down to w and z, and I'm going to try the next point, 63, 6. So I go to 63, and w has 6. And 63 goes to 6.5 on z instead of 6. So it can't be z, so that just leaves me as w as my answer, which is choice D. Another type of graph that you could see is a histogram. A histogram is a graphical data display where the data is grouped into ranges such as 40 to 49 or 50 to 59, etc., and then plotted as bars, similar to a bar graph, but as a histogram, each bar is for a range of data. And you can see that A here, you can see that range as an example. And then the table below shows the ages of players on a professional baseball team. Which of the following histograms corresponds to the table above? So looking at my x-axis here, only 2 of these have ranges. So these C and D are actually bar graphs because they don't have the range. A and B are the histograms. So that means it can't be C and it can't be D. So I'm down to 50-50 by just noticing that A and B are the only histograms. And so for 19 to 24, I need it to go up to 9 players. 19 to 24 range, the bar goes up to 9 in A. But in B, it only goes up to 8. So it can't be B. And just to double check the other 3 ranges real quick. 25 to 5. So 25 to 30 needs to be at 5, which it is. 31 to 36 also needs to be at 5, which it is. And 37 to 42 needs to be at 1, which it is. So A is definitely going to be my final answer. The last type of questions we're going to look at is being able to identify the difference between discrete and continuous data. Discrete data is a set of numbers which can be represented by distinct or separate points. So they're not connected, it's just points like a scatter plot. So an example of discrete data is the number of stairs between floors in a building. You can't have 6.5 stairs, 6 and 0.3 stairs. You can only have whole numbers. So that would be discrete numbers or discrete data because you can't have fractions. Continuous data is a set of numbers which can be represented by an interval of numbers with no gap. So this would be a graph with a line or a curve where the points are all connected. An example would be the distance traveled on a bicycle. You can go 6.3333 miles. You can go 7.25 miles. You can have those fractions and decimals with continuous data. And here are some other examples of discrete and continuous data that you can copy down in your notes. Remember, discrete is going to be examples where you can only have whole numbers for your data, and continuous is where you can have whole numbers plus every fraction and decimal in between those whole numbers. This question says, an astronaut is doing an experiment where he shoots a golf ball in a straight line. The linear function y equals 3x plus 2 can be used to find the distance between the astronaut and the ball. If the function x is the number of seconds since the ball was shot, and y is the distance away from the astronaut, based on this situation, what would the graph of the data look like? So first of all, in these questions, these answers, range and domain, are just there to throw you off. They're not going to be the answers. You're looking at, is this continuous or is this discrete? So continuous, I can have fractions and decimals, and discrete, I can't. So when you're talking about distance, you can go 0.6 meters. You can go 18.8 meters. You can have those decimals and fractions. So it's going to be continuous, which is A. Here, Arturo recorded the volume of flavored syrup left in a soft drink dispenser every hour. Which of the following names and displays the data correctly? So first of all, can you only have whole numbers? Or can you have everything in between also? And so when you're talking about the volume of a liquid left, you can have everything in between also. So that's going to be this graph here where the points are connected. And since the points are connected, that's going to be continuous. So the answer here that says continuous in graph B is D. This last question here says an airline kept track of the number of suitcases lost from a certain terminal for 1 week. Which of the following names and displays the data correctly? So the number of suitcases, you have to think, can I have half a suitcase? Can I have a quarter of a suitcase? Can I lose 1.5 suitcases? No, you could only lose whole numbers of suitcases. 1, 2, 3, 4. So that means that it's just going to be these points, and it's just going to be discrete. So discrete data is always the one with just points, and continuous data is always the one connected. So since I need discrete, that's going to be graph A, and the one that says discrete data in graph A is choice B, my final answer. Thank you for joining us today, and I hope you learned something new.